formulas. You got the basic formulas. This is for college physics, not university physics. College physics for algebra trig based. Yours is algebra trig as well as calc based. So which means that you guys will have one more formula sheet in addition to that one. All right, so this is the first page. Go all the way down to the bottom, the last page. Notice that you got the conversions here. Stuff that you need is going to be located here. All right, worksheet, simple worksheet. I'm going to get to format your solutions so everyone is on the same sheet. All right, so these are your training wheels. You will get to do problems in 3 steps. These are the steps, so you'll see a bunch of demonstrations. These are the concepts. This is your knowledge base, so we will build upon the knowledge base. This is, you're going to follow the lecture, so you will have to take notes using this. We got some simple problems this week. Problems will get more sophisticated as we go along. All right, so this week is mostly formatting. Just want to make sure that you guys know how to solve problems and show work. That's what we're going to focus on. Today, speed and velocity, that's what we will start out. And hopefully we will be able to finish this up. Okay, so we got 4 problems. Okay, so those are the ones that we will get to use. All right, so I'm going to be recording this. If you can't keep up with it, it's not a big deal. Once again, it's going to be online tonight, so you can go back and then watch it as many times as you want. Participation is extra credit. It's going to be 1 extra credit percentage point of your grade at the end of the semester. So just feel free to participate. What I like you to do is whenever we get to the multiple choice section, all right, just use the chat option. Okay, so A, B, C, and then place that in the chat. Okay, are we good? Regarding the questions that I just asked, so what's motion? Motion is the displacement of mass in space and in time. So you guys will have to take notes on that one. All right, so the motion is the displacement of mass in space and in time. Okay, so what are the only measurable quantities in describing motion? It's going to be mass is your measurable quantity. What else? You've got time is your measurable quantity. And on top of that, you have space, which is your measurable quantity. So those are the 3 things that you have to be able to measure in describing motion. All right, so the motion is the displacement of mass in time and in space. All right, so the first one that we will tackle is time. So what is time? What is time? Is time is something we get from nature itself, or is this a human invention? What do you guys think?
Human invention.
All right, you can say that it's a human invention. All right, or you can say that this is something that you get from nature itself. Who wants to say that this is something that we get from nature itself?
I say it's from nature.
Okay, explain why you think that it's something that you could get from nature itself.
I mean, we didn't create the day, so you keep on going.
Okay, I'm going to give you both of you guys 5 points for saying something. Is this a human invention, or is this something we get from nature itself? All right, guys, nature itself is cyclical. You got the days and nights, and then you get older, people get older, things die. All right, so that's what happens. Everything goes in cycles. All right, so we go around the sun, it takes a year, and within that 1 year, what happens? You end up experiencing 4 seasons. And artificially, you can take those 4 seasons and then break them into 12 months, months into weeks, weeks into days, days into hours, minutes, and seconds. Okay, now that's the way we measure time is a human invention. All right, so let's agree on that. But time itself is not a human invention. It's part of nature itself. All right, so what is time? The best definition for time comes from Einstein himself. So how do you describe time in the way we measure it? Einstein will say time is what's measured by a clock. Beautiful. It's concise, no debating it. So whatever time is, let's say time is what's measured by a clock. So that's what Einstein comes up with. All right, so last time defined in physics, time is what's measured by a clock. All right, so pick out the best answer, and when you do, just put it in the chat. All right, so A, B, C, D, just put down whatever it is that you guys are thinking, just put it in the chat. Excuse me, so what's time? All right, I see B, B. C. All right, B again, beautiful. All right, majority of you guys like B. All right, so which one is the best answer? The best, most of you guys can pick between A and B. I don't see anyone picking A, which is good. So the definition of time is what's measured by a clock. So those of you guys who pick B, give yourselves 2 points. All right, at the end of each and every single lecture, and not today because I'm still learning to use the bright space. Okay, I'm just checking the chat. All right, next time you will have a pre-lecture quiz and a post-lecture quiz. Participation quizzes and pre-lecture quizzes will have questions from the lecture, just like that. All right, so those will be review questions. All right, what's space? Well, when somebody says space, what does it mean to you guys? All right, now, because now we have to describe space in the way we measure it. What's the meaning of space? What does it mean to you? Space means different things to different people. Okay, so the gap in between 2 points will be space, so that's 1-dimensional. Or it could be an area, so that's going to be 2-dimensional. Or it could be a volume, it's 3-dimensional. Regardless of the way you actually think of space, whether it's 1-dimensional, 2-dimensional, or 3-dimensional, space is, according to Einstein, is what's measured by a measuring stick. Once again, Einstein nails it. He says space is what's measured by a measuring stick. like a yardstick, meter stick. So space is what's measured by a measuring stick. So time is what's measured by a clock. Space is what's measured by a measuring stick. That's what Einstein says. All right, so if that's the case, what's mass then? How would you describe mass? How would you describe mass? All right, so if time is what's measured by a clock and space is what's measured by a measuring stick, mass must be what's measured by, I guess, complete that sentence. So what's mass?
By a scale. I got.
Yeah, I'm going to give you 5 points for saying the wrong thing. All right, what's measured by a scale is your weight.
Wouldn't it be what's measured by an applied force? I applied 1 Newton of force and how much accelerator I could to solve for the mass?
Okay, who said that? No, that's beautiful. Who said that? What's your name?
Sarah Stewart.
Okay, Sarah, I'm gonna give you 10 points for that one. Are you a student?
Yep.
That was too concise. So we're not gonna use that definition, but that's a very concise way of saying something. I love that. All right, that's a little bit too concise for this discussion. All right, so just hold on, just briefly. Man, I wasn't expecting something that concise. All right, so mass is, you guys are thinking what's measured by a scale, it's your weight. All right, so the weight is sensitive to gravity. If you're on the moon, your weight is getting 1/6. And if you're in deep space, you may be weightless. You will still have mass. You're also thinking that if you have mass, it occupies space. That's not true either. Light has mass, but it doesn't occupy space. All right, so all of a sudden, you're kind of at a loss. So you don't know what it is at this point. So the best definition for mass comes from Newton himself. And the physics that we're doing is known as Newtonian physics. This thing is like 350 years old. Newton says mass is a measure of inertia. All right, so it's a measure of inertia. This is an abstract definition, so don't panic immediately. It'll make sense. So Newton is the guy who comes up with it. And inertia is the tendency to retain initial motion. Motion means velocity. It's a combination of speed and direction, blah, blah. Okay, so let's get back and then trying to make sense out of it. So mass is a measure of inertia, which is the tendency of an object to retain its initial motion, which happens to be the tendency of an object to retain its initial speed and the direction of that speed. If you can measure that tendency of an object to retain its initial speed and the direction of that speed, that measurement would be your mass. So the measure of that tendency becomes your mass. So I'm just going to back out of it a little bit so you have a better idea of what I'm talking about. Imagine getting hit by a fly right on the face at 60 miles per hour. You're on a motorcycle, you're going at 60, and boom, you get hit on the face. So what happens? What does that feel like? Nothing, slight pinch, and then you go, well, I think I just got hit by a fly. All right, so what happens to the fly? Dead upon impact. You'd be fine. How about getting hit by a train at 60 miles per hour? What does that feel like? It's not going to feel like anything. The impact is going to last about 1,000th of a second. The pain is not going to register, so it's a permanent out-of-body experience. So that's what happens. Getting hit by a train versus a fly. Fly comes to a dead stop, and train is going to keep on moving as if you never existed in the first place. You don't matter. Train has a much larger tendency to retain that initial speed and the direction of that speed. So if you can measure that tendency, that's the mass of the train. So train gets that tendency from its mass. So the measure of that tendency becomes the mass of the train. Fly, on the other hand, is not as massive. It doesn't have a large inertia. All right, so mass is the measure of inertia. All right, so let's stop right at this point, and then let's get back to our knowledge base. So lecture review material. What do we know? So time is what's measured by a clock. Okay, skip forward, we'll get back to it. Move on to 5. So space, defined in physics, so it's one dimension at a time. It could be the length, it could be the area or the volume. So each and every single dimension is going to be measured. So what's measured by a measuring stick is what space is. All right, skip 6, move on to 7. How's mass defined in physics? So the mass is the measure of inertia. Measure of an object's tendency to keep on moving in a straight line at a constant speed. So that's what it means. If you can measure that tendency, it becomes the mass of that object. So the proper unit for that, those are the ones we will fill in shortly. All right, so moving forward. Now let's come up with a mathematical model for whatever it is that we describe. Okay, so the motion is what we are working on. Once again, it's kinematics. All right, mathematical modeling for this one is going to be the following. So that's your mass, m is going to be your mass. It's going to get displaced along the x direction, so it gets displaced in space as well as in time. So t represents time, x is going to be distance. So mass is m, x is distance, t is going to be time. All right, so there are internationally agreed units of measurement for mass, space, as well as time. So time is going to be expressed in terms of seconds. Distance is going to be meters, and mass is going to be kilograms. For those of you guys who are not familiar, so I'm just going to write these up. This is kilograms, m is meters, s is seconds. Okay. The lecture stuff is going to be available online. Okay, so I'm going to turn these into a PDF file. Maybe tonight, maybe tomorrow. Okay, so internationally agreed units of measurement in describing motion are known as SI, Standard International Unit System, or known as the MKS unit system. So M stands for meters, K stands for kilograms, S stands for seconds. Okay, so that's what we got. Okay, another thing that we need to discuss, I say displacement of mass in space and in time. So we need to discuss what distance is and then what displacement is. So this is our subtopic, so distance versus displacement. Distance is the total path traveled. All right, so that's the total path traveled is going to be, it says total path, it's the total path traveled. The displacement is the shortest distance between 2 points, but the final position is going to be indicated by an arrow. Okay, so let's explain that. All right, so this lecture is coming to you from Chicago. I'm in Chicago. I know you guys are near Houston somewhere. All right, because of COVID, I'm not going to be able to travel right now. My wife is pregnant, so we decided to shelter in place, so we're going to be here. So I'm going to give you a Chicago example because I've been here for over 20 years. Imagine that you're rich enough, so you have a boat. So you take your family and friends out to a boat trip in Lake Michigan. All right, you spend about 5-6 hours, and now you're meandering around, you're coming back, and then the engine breaks down. All right, so this is where the engine breaks down. You need help, you call up the Coast Guard. What information do they need? Okay, what you need to know at this point, you know a couple of things about your situation. You know that you've been out in the lake for about 3-4 hours, and you also know that you traveled about 100 miles. Okay, is this information in any way relevant to your survival at this point or rescue?
No.
No, absolutely not. No, because Coast Guard doesn't care that you were in the lake for 3-4 hours. They don't care that you traveled 100 miles. What is it that they want? They want your location on a coordinate system, on a map, right? That's what they want. They want to know exactly where you are with respect to where they are. So what they're interested in is your location on a coordinate system. All right, so it could be a map. In our case, it's going to be XY coordinate system. And then now we have to find the shortest distance between these 2 points, and then so that they can locate you on a map. This becomes your displacement. As it so happens, you're about 30 miles in this direction, northeasterly direction, all right? And then there would be an angle and all that stuff. So this is your displacement. So displacement is the shortest distance between 2 points with your location indicated as an arrow with respect to your reference point. And distance is the total path traveled, so don't get them confused. Displacement is also known as a position vector, so it locates you on a map. Okay, so I said vector, so which means that we're going to talk about vectors briefly. All right, there are 2 things regarding numbers. You have vectors and you got scalars. All right, scalar is just a number. It's going to tell you how big or how small something is, so it's got a magnitude. All right, so time has a magnitude, so that's a number. Pressure is, so it's pressure, you got weight, you got speed, how fast you're moving, you got the temperature, so these are all numbers. When you're dealing with a vector not only is going to have magnitude, it's also going to have direction, like force. You can push on something in this direction, you pull on it in the opposite direction. Notice that when you're dealing push and pull involves a direction. Acceleration is another example. You can speed up in this direction, you can slow down in an opposite direction. So once again, that's a vector. What else is a vector? Velocity is a vector. Now, speed is how fast you're going. It could be 50 miles per hour. But as soon as you indicate direction, hey, I'm going 50 miles per hour north, now you're dealing with velocity. All right, so as soon as you specify direction, the scalar turns into a vector. All right, so these are the basic definitions that we will need to play with. All right, so let me just get out of here. All right, so we discussed distance, discussed displacement. All right, so I was in California last year for about a year. I had a 1-year temporary gig. So while I was going there, I decided to take almost a week. I meandered around, did a lot of sightseeing. And so this was the total path traveled. I noticed that this is my final location, so this would be my displacement. So this is the shortest distance between 2 points with the final position indicated as an arrow. So this becomes a displacement vector. All right, so distance is the total length traveled or path traveled, so it's a scalar. Displacement is the shortest between 2 points with the final position is indicated as an arrow, so that becomes a vector. Scalars are just a bunch of numbers. They just got sizes and magnitudes. Time, distance, and speed are prime examples. Vector is anything that is magnitude as well as direction. Velocity, acceleration, force are prime examples. So anything that is direction. All right, so let's get back to the review material. So let's fill in the gaps. All right, so I'll go over what we already know real fast, and then I'm going to ask you guys to fill in the gaps. All right, so motion is a displacement of mass in space and in time, right? And so the mass, space, and time are the only measurable quantities. Time is what's measured by a clock. So what's the proper unit?
Seconds.
It's going to be seconds. Give yourself 2 points for that one. Space is what's measured by a measuring stick. So what's the proper unit? It's going to be meters. All right. Give yourself 2 points every time you answer a question. So how's mass defined in physics? It's what's measured.
Kilograms.
Okay, so mass is measured every no shape proper unit is kilograms. Very good. What does MKS stand for?
Meters, kilograms, and seconds. It
Okay,
refers
meters.
to the metric system of measurement.
Okay, very good. Meters, kilograms, and seconds. Metric unit measurement system. All right. Give yourself 5 points. All right. Distance versus displacement. What's distance?
Total path.
A scalar quantity.
It's a scalar quantity referring to the total path traveled. Okay, give yourself 2 points. And what's displacement?
Distance between 2 points. Shortest distance between 2 points.
All right, that's a vector quantity, the shortest distance between 2 points.